China just built a chip that's 1,000 times faster than NVIDIA's best. Not 10% faster, not twice as fast, 1,000 times faster. And yes, the numbers have been verified. You're about to find out exactly how they pulled off what everyone said was impossible. Because when a chip processes in seconds what used to take hours, everything changes. But first, you need to understand just how insane these numbers really are. The numbers that broke physics. Right now, NVIDIA's H100 is the fastest chip on the planet. It's the chip that runs ChatGPT. It's the chip that trains every major AI model. It processes 2,000 trillion operations per second. That's the benchmark. That's what fast looks like. Until now. Because China's new chip doesn't process 2,000 trillion operations per second, it processes 2 quadrillion. That's 2 million trillion operations per second. You heard that right. When independent labs ran the tests, they couldn't believe the results either. So they ran them again. Same numbers. Here's what that actually means. Take a task that requires 10 hours on NVIDIA's chip. Complex AI training. Massive data processing. The kind of computation that makes you start it before you go to bed. On this chip, 36 seconds. Not 36 minutes, 36 seconds. But here's where it gets absolutely insane. This isn't just about speed. It's about what becomes possible when you have this kind of speed. Calculations that were too expensive to even attempt, now they're instant. Simulations that required scheduling time on a supercomputer, you can run them on your lunch break. The entire concept of computing time just became irrelevant. And the craziest part? This chip runs cool. No massive cooling systems. No data centers full of equipment just to keep it from melting. It's fast, and it doesn't even break a sweat. Which brings us to the question you're probably screaming right now. How is this even possible? The technology that changed everything. Every chip you've ever used works the same way. Electrons flow through silicon. Billions of tiny switches flipping on and off. It's been that way for 50 years. And for 50 years, we've been running into the same problem. Heat. The faster you push electrons, the hotter the chip gets. The hotter it gets, the more power it needs. The more power it needs, the more it costs to run. Eventually, you hit a wall. A physical limit where making it faster just isn't possible anymore. Silicon can only do so much. That's why everyone's been chasing the same incremental gains. 0.10% faster this year, 15% faster next year. Tiny improvements that cost billions to achieve. But China looked at that wall and said, what if we don't use electrons at all? Their chip doesn't push electricity through silicon. It uses light, photons, instead of electrons. And photons move at the speed of light. They don't generate heat the way electricity does. They don't have the same physical limitations. It's a completely different game. Here's where it gets wild. Traditional chips process information in sequence. One calculation, then the next, then the next. It's fast, but it's still linear. This photonic chip processes multiple operations simultaneously. Hundreds of calculations happening at the exact same moment. It's not just doing things faster. It's doing more things at once. The breakthrough came from something called optical computing. Scientists have known about it for decades. But nobody could make it stable. Nobody could make it scalable. The technology always fell apart when you tried to make it practical. Until Chinese researchers figured out how to stabilize the light paths. How to control photons with the same precision you'd control electrons. How to build a chip that doesn't just work in a lab, but works in the real world. They didn't improve the old technology. They replaced it entirely. And when you replace the fundamental way a chip operates, you don't get 10% faster, you get 1,000 times faster. Now, here's what that kind of speed actually does when you put it to work. What 1,000x speed actually does. Let's talk about AI training. Right now, training a large language model takes 3 months. 3 months of running thousands of NVIDIA chips 24/7. The electricity bill alone costs millions. Companies plan their entire roadmaps around these training cycles. It's not just expensive, it's slow enough to limit what anyone can even try. With this chip, that 3-month training cycle takes 2 hours. 2 hours! Think about what that means. An AI model that cost $10 million to train now costs $10,000. Ideas that were too expensive to test become experiments you can run over breakfast. The barrier between "let's try this" and "here are the results" completely disappears. But it's not just AI. Video rendering that takes 12 hours, done in 43 seconds. Weather simulations that require a supercomputer running for days, finished before you can grab lunch. Drug discovery simulations that take weeks to model how a molecule interacts with the human body, real-time results. Here's the part that should make your brain hurt. Medical imaging analysis that currently takes a radiologist 20 minutes per scan, this chip does it in 1.2 seconds. And it doesn't just do it faster. It can analyze every pixel, every shadow, every detail that a human eye might miss. Because speed. This extreme means you can check everything. Real-time language translation with 0 delay. Not the awkward pause you get now. Instant. You speak, it translates. The other person hears it in their language, as if you're speaking directly to them. Graphics rendering that seemed impossible? We're talking photorealistic environments generated on the fly, not pre-rendered, not cached, created in real time as you move through them. Video games that look like real life, because the chip can process every ray of light, every reflection, every shadow, instantly. But here's what really changes. Right now, there are problems we don't even try to solve because the computing time would be absurd. Climate models that would take years to run. Genetic sequencing that would require months of processing. Engineering simulations that are just too complex to calculate. This chip makes all of that trivial. Problems that weren't worth attempting become problems you can solve before dinner. The boundary of what's computationally possible just moved so far forward that we're standing in completely new territory. Which raises the obvious question: when is this chip going to be mass-produced? When this chip hits the market, here's what you actually need to know. This chip came from the Chinese Academy of Sciences Institute of Semiconductors in Beijing. Not some unknown startup. Not a lab making wild claims. This is China's premier research institution, and they've already moved past the prototype phase. Mass production starts in 6 months. Not someday, not in a few years. 6 months. The fabrication plants are being built right now. By the end of next year, these chips will be shipping to data centers across China. And that's when everything changes for NVIDIA. Because right now, NVIDIA doesn't just lead the chip market, they own it. Every major AI company in the world is buying H100s. Every data center is packed with them. NVIDIA's worth over $4 trillion because they're the only game in town. If you want cutting-edge AI, you buy NVIDIA. There's no alternative. But in 6 months, there will be. Think about what happens when a chip that's 1,000 times faster hits the market. Chinese AI companies switch immediately. Why wouldn't they? Training that costs 3 months and millions of dollars now takes 2 hours and costs a fraction. It's not even a decision. It's obvious. But here's where it gets devastating for NVIDIA. Once Chinese companies start using this chip, they'll develop AI applications that companies using NVIDIA chips literally cannot build. Not because they don't have the talent, not because they don't have the ideas, because their hardware is too slow. A Chinese company builds an AI system that processes real-time translation across 200 languages simultaneously. A company using NVIDIA chips tries to compete. Their hardware can't keep up. The application lags. It fails. They can't deliver the same product because the chip won't let them. That's not competition. That's obsolescence. And NVIDIA knows it. They've been working on photonic computing for years, but they're nowhere close to production. They're still testing, still optimizing, still trying to solve the stability problems. Meanwhile, China's Institute of Semiconductors already solved those problems, and they're building factories. Here's the brutal math. If you're running an AI company and your competitor has access to chips that are 1,000 times faster, You don't compete. You lose. It doesn't matter how smart your team is. It doesn't matter how much funding you have. You're bringing a calculator to a supercomputer fight. 6 months from now, Chinese data centers will be processing calculations at speeds that make NVIDIA's chips look like they're standing still. AI models will be trained faster. Applications will run smoother. Breakthroughs will happen quicker. And every company outside China will be watching, wondering how they're supposed to keep up. NVIDIA can't just release a faster chip. They'd need to rebuild their entire architecture. They'd need to abandon silicon and go photonic. They'd need to solve problems that took China's top research lab years to crack. And they'd need to do it all while China's already in production, already shipping, already building the next generation. This isn't about one company losing market share. This is about the entire global AI industry realizing that the hardware advantage just flipped. The country with the fastest chips doesn't just move faster, it dictates what's possible. And in 6 months, that country won't be the one where NVIDIA is based.